Hi, in this video I'm going to talk about comparing box plots. So if you recall, a box plot is divided into four quartiles where you have the minimum, Q1, which is at the 25th percentile, the median, which is technically your Q2, Q3, which is your 75th percentile, and your maximum value. So what does that mean? Each section of your box plot is always divided into 25%. So from the minimum to Q1 is 25%, from Q1 to the median is 25%, from the median to Q3, 25%, and from Q3 to the max is always 25%. So you actually don't know unless you see the data, how many observations you have in each quartile, but you know it's always 25, 25, 25, and 25. All right, so recall the median is always in between your Q1 and Q3, somewhere in the box. It doesn't have to be exactly in the middle, could be anywhere in your box. QR is always your Q3 minus Q1. Remember, if you want to read what that is, you can always draw a line from your median down, and that you'd be able to read that it is 350 is your median. If you want to know what your Q1 is, you would just read directly down, so it'd be roughly around 330, and then the same thing for Q3, you would read down, and you can do the same thing for each observation that you see. All right, looking at our box plot, you can either have a horizontal box plot, as this one is, or you can have a vertical box plot. Remember to always look at your number line, what the numbers represent. Read the title so you know what it's talking about. And here on the right, again, you have your 25th percentile corresponds to, and right here, your 50th percentile, that's your median. Your median is always going to split your data into 50%. Your Q3 right here, and your maximum value. Now, one thing from a box plot, you cannot tell the shape, whether it's unimodal or bimodal, but you can tell if it's skewed or symmetric. So let's take a look at the difference. All right, how to tell the shape of a box plot. When you look at your box plot, this is, if you can draw a curve. Now again, you wouldn't be able to tell if this is unimodal or bimodal, but you can kind of look at your box plot and see where your median is. So in this case, here is my median at my Q2, and there is a long spread between my first observation, my minimum value, to my median. So it's more spread out. Remember, this is still 25% of the data is here. So even though there's more of a spread, it still contains 25%. And here it's contained 25%, and so on. So if we're looking at the symmetric, this looks more evenly spread out. So it looks more like a box, where this is more spread. If you look at the right skewed, the median over here, there's less of the spread. So from here to here, this is 50% of your observations are right here. And if you compare the bottom 50% to the top 50%, you could set the top 50% is more spread out. So we say this is right skewed. So if you could imagine drawing a curve, and again, you wouldn't know if this is unimodal or bimodal or how many modes it has, but the tail would be veering off to the right. How to compare more than one box plot. All right, so looking at these box plots side to side, it doesn't matter how small the box or whisker is. Each one represents 25%, as I stated before. So this is 25%. From your Q1 to your median, that's 25% here. And you can see for the second experiment too, this is also 25% right here. So experiment 1 is more spread out from your Q1 to your median than experiment 2. And if you wanted to know exactly what that spread was, all you would need to do is look at the number line and just take the difference of those values. Same if you wanted to know the IQR. Now, which IQR do you think is the smallest? So if you want to just pause the video and decide, if you said experiment 2, then you are right. So the IQR for experiment 2 right here is much smaller than the IQR for experiment 1. For experiment 3, this would be the IQR, and experiment 4. So smaller boxes and whiskers show the data is closer together, and that means that is low variability. And larger boxes and whiskers has further apart means that you have high variability, so the spread is much further. All right, so here we have distributions of gas mileage. So if you want to pause the video and see if you can compare the median, if you can compare the IQRs, if you want to compare the minimums to the maximums, then go ahead and do so. All right, so for the 3 box plots where it says distribution of gas mileage, I can see that the first one, which is number of gears, the ones that has 3 gears, has the smallest miles per gallon at about 16. If you're looking at the number of gears right here, 4, this one has a median of about, I don't know, this would be maybe halfway between 20 and 25, so maybe about 22.5 or 23, whereas the median here has a miles per gallon of about 20. So you can easily compare the medians when you have your box plots lined up this way. If you had to compare the shape, you can see that somehow this appears to be skewed to the right because the whisker on the right is much longer. Same with the number of gears for 4. This appears to be skewed to the right again. And for number 3, it's kind of hard to tell, but this appears to be somewhat symmetric, more of a symmetric distribution. All right, so remember when comparing dot plots, stem plots, histograms, no matter what it is, you're always going to use context, so make sure you talk about what it is you're looking at and describe it using SOCS, meaning shape, outlier, center, and spread. Remember to always use comparative language, such as less than or greater than or similar. Remember, do not use definite language. You want to say approximately. You don't want to use anything definite. So remember when you're comparing to always not just list the first one and the second one, you want to connect them together using the comparative language. All right, so go ahead and try to compare these distributions. Pause the video. Remember to use all of the acronyms from before: shape, outlier, center, and spread, and always in context. In this case, we are talking about household tax cuts. So go ahead and describe the 2 box plots. All right, for the shape, if you said that the first box plot A is somewhat skewed to the left and the box plot of B is somewhat skewed to the right, then you would be correct. One way you can describe it, something like this. So the context would be household tax cuts. So this would be your context right here. You want to talk about what it is the box plot is representing. So household tax cuts under Plan A are left skewed, whereas they are severely right skewed under Plan B. There are no outliers under Plan A, while there are several outliers higher than 12,000 in Plan B. So you can see right here they're higher than $12,000, and so you want to say where those are. The median tax cut under Plan A is about $4,750. So again, if I drew a vertical line from my median, you could see that it is about $4,750. And if I drew the median for box plot B, it would be somewhere here, which is about $200. Plan A has a higher IQR, about 2,750, than Plan B, about 600. Again, remember the IQR, you want to take the difference between Q3 minus Q1 and Q3 minus Q1 here. And so that would be about how you would want to compare two box plots.